Yeah. Okay. Good morning once again. I'm very, very sorry for Tuesday class. I had to cancel. I was a little bit down on Tuesday. So let's see how far we can go today. And let's see, because I have here your lesson seven Zyvox activities is due on the 17th. That'll be next week, if I'm not wrong. Next week, Friday. So let's say I hope we are able to cover um, the most important and essential concepts in this lesson before next week Thursday. Oh, look, until next week Thursday class, not before, until next week Thursday class. So we will introduce the concept of user-defined method. We have been using method, we have been talking about method, we have been discussing, we have been calling, we have been accessing method since lesson two of this class, of this course rather. So method shouldn't be something new, something new to us in this course. However, user-defined method is a new concept we will introduce in lesson seven, and it is very, very important. This lesson is very, very important. Don't forget your exam two, that is the second exam, by the end of the semester, which will be the end of this month, we will take from lesson five, six, and seven. So it will be from lesson five, six, and seven. So it is this lesson is it's very, very important. And trust me, it's not difficult. It's not difficult. Um, so what are we going to learn in lesson seven? What are we going to learn with this in this lesson? So the basis of user-defined method. How do we declare it? What are the necessary things we must put in mind when declaring a user-defined, when using, that's the word, when accessing, when calling a user-defined method? What are the important steps we have to take? Extremely important steps we have to take when declaring our user-defined method, and when we're using them, that is when we're calling the specific method into action. So the basis, we have to understand this, and we will don't you can see from lesson, if you agree with me, from lesson six until lesson seven, even from lesson five, you can see we have been merging concepts together. So in our loops, we talked about the conditional statements we discussed in lesson four. We start using the relational operators, the logical operators in in coding, in developing instructions for what? For our Boolean expression, for our loop, how we want our loop to operate, how we want it to execute, the number of iteration, how we want it to iterate. So you can see we have been bringing these concepts, different concepts you have learned in this class together. So the same thing for our array, we can see where we have to use for loop to access our array. Now we have something we call an enhanced for loop specifically for arrays. So you can see these concepts are coming together, and it's the same thing we're going to do in lesson seven. So in lesson seven, we have to use loops, branches. We will be using this concept, the concept we've learned in lesson five and lesson six. We'll be bringing these concepts together also in lesson seven to see how we can use user-defined method with loops, with arrays, things like that. So you will see a lot of concepts coming together. Now our code will become more complex. It wasn't the way we started out, we're just doing one directional, just one kind of um, instruction we're giving the compiler some kind of instruction that just in one direction. But now we have introduced loops, we have introduced array, how we can save, how we can call the array, and now we'll see how we can use our own method, how we can declare our method as a programmer. You don't have to use inbuilt method for your code. Trust me, it is not even the most efficient way. It is not the most efficient way when it comes to writing program. I mean, complex long programs. Because if you have to use all predefined, probably the predefined cannot do the kind of problem, or cannot solve, that's the word, cannot solve the kind of problem we have at hand. So what are we going to do? Now the programmer needs to sit down and do what? Declare your own method so you can reuse this method over and over and over. You're declaring the method, it is your method to solve a specific problem. That's the concept of user-defined method. User is defining that method. It is not a predefined method. It is not in Java library, It is not coming within the Java library. The user is declaring, and you're declaring it based on the problem you have at hand. So you have some kind of problems at hand that you need to solve using programming instructions, and the user-defined method is not efficient enough to handle. I'm not saying the inbuilt method will not solve that problem, but it is not the most efficient way to solve that problem. So what do we need? We need, as a programmer, to sit down and write our own methods, which we now call the user defined method. That's just user is defining that method. User is generating the method, as the user here in this context is not when user is providing the values. You're having an interactive program. This is user here in terms of the programmer itself. I am the programmer and I am declaring my method. So it is called user-defined method because it is not within the compiler. It is not predefined within the Java class. It is not predefined within the Java class. I, as a programmer, is generating, this kind of method. And we need to understand what are the common errors, with this kind of method. Very, very important. And we will, the beauty of this lesson and the beauty of lesson 5, 6, 7, why I love this lesson so much is because they are not just standalone. Our code is becoming more complex, and I love the fact we are bringing concept from all the lessons that we've learned. We are bringing concept from lesson 3, concept from lesson 2, concept from lesson 4, concept from lesson 5, and concept from lesson 6. And now we will use all the concept we have learned, from lesson 2 until lesson 6. We will use them all together. You can see talking about loops, talking about arrays. We can do loops without having a conditional statement, things like that. So we will bring all this concept together. Of course, we will have Java documentation. We have to read. You must learn how to read Java APIs. You must learn how to read them because this is like your dictionary. I do call that dictionary because you can always go there to understand the meaning. You go back there and say, oh, if I have to use this method, how will I use it? What will it do? What would this specific method do for me? So we will see some Java documentation on methods. We have been using that, I think, in our when we're talking about the string data type, when we talk about the character data type, we talked about Java documentation, and we will see more of that also with the user-defined method. Any questions on the previous concept we have introduced in this class, we have discussed in this class, from loops, array, all the way from lesson 5. Any question? Do you have any question? Because we are now building up. We will start building up from what we have learned from this lesson. So I need we need to be on the same page. We need to be on the same page and to be sure there is no confusion. There is no confusion. We are on the same page, we have the same synergy. So when I'm bringing in this new concept, you're like, oh, now we're connecting. The purpose of this lesson is that we want to connect those dots. We want to connect the dots from lesson 2, lesson 3, 4, 5, and 6. So it is very, very important we understand all the previous concepts we have introduced in this class. Thumbs up if there's no question, and we are good to start with the methods. Thank you. Thank you. Thank you, guys. So, when we're talking about lesson 7, like we have for the other lessons from lesson 1 on to 6, we have the lecture note here. You can follow along with me or in class. However, you don't have to wait until class period until we're meeting. So what can you do? You can, download this lecture notes, go through them. If you have any question, send me inbox, message me on Canvas inbox. Um, interrupt me in class. After the meeting, you can wait and we can discuss some other question that you have or some clarification you want to make. So it's the same thing that we have been doing for the previous lessons. So we have two presentation we will go through for this specific lesson, and we also have the in class. So these are the different challenge activity we will be using for our class demonstration of this concept. So let's go to the part 1. I have it open here already. And this is the part 1 of our lesson today. And what is this saying? What is this? But we have been talking about methods. Trust me, from the beginning of this class, we have been talking about method. Can anyone, you can, unmute yourself, use the chat. Can anyone, what is your understanding? Just tell me your understanding of a method. We have been talking about method from lesson 2. So can anyone in class today share their opinion of what they think a method is? You can also use, maybe you can just cite an example. Maybe tell me what is an example of a method. We have been talking about method. It doesn't have to, we have been talking about method. Inbuilt methods. Inbuilt methods. Let me put it down. But today we'll be talking about user defined. But I want the general opinion what a method is. What do you think? Willing to share? Unmute yourself, use the chat. I need this class to be interactive, guys. It's boring, only me talking. I don't have to call names. We have few people on the call, so someone willing to go share. What is the method? Just you can give an example of a method we discussed this in lesson 3, lesson 4. Yes, pretty sure of that. Anybody? Isn't it a process? Console.log. Process. What do you mean by process? When we say it's a process, I want to get the word process. What are we processing? Brunas, what do you mean by process? What do you think? process. I just want you to get the right word, Yeah, you're absolutely right. But process, what are we processing? Like an action. Thank you. That's the word. Like an action. So, what is a method? Thank you very much, Bianca. She just said it. What is a method? A method usually contains more than, it could be one or more lines of code that we execute to perform a specific, it's performing a specific task, action, it's performing a specific action. You're calling that method to do something, to perform a task. What are we using? You're accessing, you're calling. And we're saying we have class. And within our class, we have what? We have different methods. Within a class, within a Java class, we have methods. Within a Java class, we have methods, we have properties. And what is the method doing? The method is performing a specific action. So we call it. I'm calling you, hey, go and do this. That's what the method does. Hey, come here. It's predefined. It's already inbuilt. Hey, come here. I need you to, hey, come here from the math class. Come here from the math class. I need you to calculate the square roots. So the method here is the square roots. Within what? Within which class? The math class. So you call it, hey, come here. I need you to calculate the max, the maximum number. Hey, come here. I need you to calculate the minimum number. So where is this method? These methods are within the math class. So they're performing what? A specific, method are always there to do what? They're performing a specific task. They're performing a specific action. Hey, system.print out. Print out in a new line. Printing in a new line is a specific, it's a method. What are we telling it to do? Print on the screen. System.out. System.out. When we say system.in, take this thing from the keyboard. Is an input from the keyboard. Take this output to the keyboard. I don't know. Do you guys understand? Thumbs up if you understand what the method is doing now. Yeah, it is what? It is just saying, hey, come here. Go and do the stats. But we cannot call this specific method without doing what? Without specifying the class that belongs to. So that's why anytime we have to declare a method or we want to call or we want to access a method, we do what? The class dots the name of the method. How do we? It's very important. The dot operator here. We also call it, that's what we call the access operator as well. So you say math dots square roots. And what is that saying? I want us to see example of that because we need to understand. Let's look at the math class. So all you have to do is just maths Java, and we will go directly. Just press that on your just type in that on your browser, and you can access. We can access what? We can access the what? The API, the documentation. And this is the class itself. It's a math class. However, because we also differentiate between this type of method, we talked about the static method and the instance method in our lesson 3. We did that. I would say the static method. For the static method, what happens? You don't have to call the class. You don't have to call the class. But for the instance method, we have to call the class. So example of an instance method is only what? Your scanner, example of an instant class rather is only your scanner class. And the scanner class, you have to import, you have to access that class. And the system.in is the method you're using there. You're telling, hey, system, that's one of the methods, system.in. I'm telling my compiler that I am using this specific method that will grab values from the user. However, in the math class, because most of the method within this math class are static method, we do not have to. Before the class, we do not have to access. We don't have to say java.util or whatever.math class. We don't need that because they are mostly static. How do we access static method? How do we access them? We access them via the dot operator. The dot operator, that's the access operator. And what do we have to do? All we have to do is that maths, which is the class, dots, the method we want to use within this math class. Now the method, you want to use within the math class. So it's always maths, for instance, math.floor, math.log, math.max, math.mean, math.rand, math.power. This is how we access method within the math class because they are mostly static method. However, when we are talking about method within the instant class, we need to put the instant class itself. And that's when we're talking about, for instance, the scanner class. We need to import the scanner class because it's an instant class. To access the method within the scanner class, we need to import the scanner class. The scanner class. However, for the math class, no, most of the methods within the scanner class are static method. All we have to do is to use what? Our dots operator to access this method we want to use within this class. And math.random, math.power, math.max, math.mean. And these are the different methods. And the documentation here is already telling you what the parameters within this, you're passing within the method will look like. Any question on this? Also, if you understand what a method is doing, how it says a method, Thank you guys. So a method is also called a function because we are calling it, we are accessing it to perform a specific task. So we can, in other textbook, you can see that they're calling methods functions because they are actually performing a specific function. They are performing a specific function. And don't forget, how do we access this method? How do we access them? Always via the dots, the dot operator. That's you're putting your access operator, math dots, whatever method you want to access within a specific math class, for instance. So now we have learned about, we have talked about user-defined methods. We have talked about how to access the different user-defined methods, like the math class, the scanner class, the string class, the character class. We talked about those methods in our lesson 4, and we already talked about how do we access them. You want to use substring, for instance. Substring is a method within what? Within the string class. We talked about all these things. So please, if you need to refresh your memory on this concept, please go to your lesson 2, lesson 3, lesson 4. I think from lesson 2, we're talking about the math class. And we talked about it in lesson 3, lesson 4. Very, very important because going forward, what are we going to do? We are building up. we are building up on the different concepts from all the lessons that we have learned from lesson 2 until lesson 6. So, this method, what are they doing generally? This method are solving problems. They're solving problems. They're performing basic mathematical calculations, and they're building mathematical expressions. It's a function. They're performing a specific task. So, now we going forward, we are not using the user defined, the system predefined the predefined method within the system within the Java class again. Now we are talking about we as the programmer, myself, yourself, as the programmer, having a specific problem at hand, and you want to be efficient in solving this problem. You don't want to rely on just user-defined and you don't want to write within just the main method. That's just it. Now we want to define our method as the user. We want to use our own defined method in solving a specific problem. What do you think? What is the benefit? Why do I have to? This predefined methods are already available in the different classes. But me as a user, I still want to declare and and have my own methods. Why? Why do you think sometimes it's necessary to have your own method? We have discussed one reason. You have special problem at hand and you don't want, you don't want to use the predefined methods for the specific problem. You want to define your own method. What is the purpose? What will it do? Of course, you will be able to reuse this method even outside the main method. So you can call any of the method you have declared even outside the main method. Before now, we have been writing our program within the main method because all the methods we are using are predefined methods. They are inbuilt methods. Now we want to start writing our program outside the main method. Outside the main method. And this will allow us to do what? To reuse our method. So you can have method maybe at the beginning of your code, and you've written thousands of code, and you still reuse that method because it's really outside your main method. So you can call it. And that in programming language, what do we call that? We call that modularizing. You're putting all your method, you're modularizing it in different modules. And you can reuse them. You can call them at different points. It's yours. You created it, you generated it, so you can always use them the way you like. You can use them when you're not restricted. You can call them at any time. And this will reduce technical debt. I've been talking about technical debt. I've been talking about redundancy in our program. As a programmer, you have to be efficient in your code. You're trying to solve a specific problem that it could take just 2 lines of code. And because you have to use predefined method, inbuilt method, it's gonna take 100. Don't let me exaggerate. So it's gonna take 20 lines of code, for instance. So as a programmer, what would you think is the most efficient way? Of course, declare your method and use 2 lines of code. So anybody see your code and understand it and will be able to use this type of to understand what kind of problem you're solving with your code. So that being said, overview of what we'll be learning in this lesson generally, how to create user-defined method how to invoke. I've been saying we have to reuse them. So how do you invoke them? How do you reuse them? How do you pass arguments to the method? To determine the difference between void and value returning method, we will talk about that. We will talk about that in this class. And to use method overloading to determine the scope of local variables, we will discuss that in this class. So let's start today's conversation. We have reminded ourselves what a method is. We have talked about the inbuilt methods, why, when, how we can use them. But now, let's talk about user-defined method. What are user-defined method? A method defined by the programmer. A method you are declaring to perform what? A specific action, to perform a specific task. We also know them as what? Functions, like I said, because they're performing, they're doing a task, they're doing they're performing a specific function. They are to return, they may be returning, they may not be returning something. So we will talk about that in a few seconds. But when we're talking about it's just the same thing like we have for our regular methods. When we're talking about our regular method, we have to pass parameters, I told you. And that's why your API is very important. I'm using square root. I know within the square root, I need two parameters, the power and of course the base. So I need the two parameters, even for square root, which is a specific method within the math class. It's the same thing for your user-defined method. It's the same thing. We also write those line of codes to perform a specific task, and we have to pass the parameters into the method as well. So it's exactly the same thing we have with our regular methods. I mean, the inbuilt methods, that we do the same thing for the user-defined method. So extremely the same way we declare, however, they are a little bit different. They're a little bit different. If you remember, in our main method is always static void main. So it's always like that. And we write within the main method. But here, what are we doing? What are we doing? So what do you think we must do? How do we declare? How do we declare our main method? How do we declare our user-defined method here? It's similar to how we declare our main method. Of course, we have to call the specific function. So we have to call a specific. So we have to call a specific function we want that, we want that method to be doing. So what is the basic syntax? And I'm going to go, I think we will talk about examples. So what is the basic syntax for declaring our user-defined method? Modifier. What is a modifier? How we want our method to be accessed. Just the same thing that we have here. How is this method accessed? Is it it's private, public, or static? So similar process, similar thing here. I want what? Our method to be accessed. That's the first thing here. And that's what we call our what? Our modifier. Our modifier. Then the next thing is always the return type. And we will talk about that in this class. So for our main method, it's always the void method, static void. Static void. And we can also have void here in our user-defined method. And we can also have the value, we can have a value returning method. So we can have a value returning method that will be maybe an integer, a float, a double. We want our method to return a specific data type, a specific data type. So it could be void, it could be integer, So there are two types, void of value returning. So value returning could be integer, it could be float, it could be strings, it could be character data type. Data type you want your method to return. And of course, another important concept here is the method name. Don't forget, method name, always use it to define. You're giving your method whatever name you want to name it. However, you have to name it something that is similar to the problem at hand you're trying to solve. You know, problem at hand you're trying to solve. And don't forget about the naming convention. Don't forget about the camel case. We talked about that in our lesson too. And we talked about how the classes should be named, how our methods and variables should be named. For methods and variable, we discussed it has to be what? The lower camel case. The lower camel case, that is the first letter has to be in lowercase. The first letter, the first word. So if you're joining two words together, the first letter of the first word has to be in lowercase. And if it's just one word, it has to be in all lowercase. And of course, our parameter list. We've talked about parameter list. We've talked about in terms maths that square root. Into it, we have what our base and the power. So what is the parameter here? What is the parameter? You know, these are often optional in they're often optional depending on the kind of function we want to perform, on the kind of function we want to perform. So, and of course, our calibres, because we can have more than one line of code. And we already talked about the importance of the calibres, which is like giving, the purpose of the calibres is to give your intent in your block belonging this group of you're grouping your code. These lines of codes are grouped together, they belong to each other. This other lines of code as well belongs to the specific function. So it is very, very important when we have more than one line to have our calibres, and within the calibres we have the code to be executed. What should happen? What should happen? The code, the instruction itself to be executed in our closing calibres, which tells us the end of that block of code. Any question, clarification you want to make? Any questions or clarifications to make? Thumbs up if there's no question, and I want us to go back to the previous slides and see what is this example saying. Now we understand the declaration, how to declare our user-defined method. Our modifier is very important. It tells. And here is what is the modifier here? What is the modifier here? Can anybody tell me? I just said that a few minutes ago. You can use the chat, unmute yourself. What is our modifier in this example here? Let me take my pen. What is the modifier in this line of code? This line. What is the modifier here? We said we need our modifier, we need our return type, we need the name of the method itself, and we need the parameters, the list of parameters that should be in parentheses. So what is our modifier here? You guys just thumbs up a few minutes ago that you understand this concept of defining. So what is our modifier here? In this first line of code, the second line, because there's a comment. Okay. Thank you, Bianca. Static. This is our modifier here. Static. The word static. The word static is our modifier here. And we said it could be public, it could be private, it could be static. What is our modifier telling us here? It is telling us that this how we want to access this method. whatever modifier here, we will see the importance of modifier going forward when we are talking about accessing this method, this specific method, invoking that method. So, a private method. A private method will only be used within that specific method. Within, when it's only within the method, it can only be accessed within the method, within the specific method. So if we have a public method, of course, you can use that anywhere at any point. It doesn't have to be within the method it was created, when it was created. It can be used, it can be invoked, it can be accessed. So our modifier is telling us how. How. So the static is telling us how we access, how we're going to access this method. And we said it could be static, it could be private, it could be public. And the next one is always what? Our return type. What will this method return? Void, maybe. Other type we can return is our value returning. And we say when it's a value return, we are returning a specific data type. It could be an integer, it could be a float, it could be double, it could be string, it could be character data type. What data type we want to return? So this is always the return type. And here you can see we have void as our return type. And what follows the return type? What follows the return type is the name. That's always the name of the method itself. This is user defined. You could name your method whatever works for you. However, it is recommended to name your method in a way you will understand, that makes sense, that is logical. You can define it, you can name it whatever, but name it in a way, that will it will make sense to anybody picking up your code to read, to understand it. So immediately after, then we have to pass our parameters. However, I said this is optional, depending on the purpose, what we want this method to do. So we pass our parameters, just the same thing we have, for instance, in our maths dot square roots method. So we pass our parameters. Parameters are always within parentheses. And immediately we have our opening curly brace because we have more than one line of codes. And when we have more than one line of code, this is telling the compiler, this is telling the compiler, all this code from in sum, from calculating the sum, then printing out the sum belongs to this method, the specific method. So, and of course, this is what the function. The function. This is the body. This is the body. This is the body of the method itself. This is the body of the method itself. What will they, what will the method be doing? What will the method be doing? So the first line here, you can see, what are we doing? We're declaring. So we call this method declaration or definition. This is where we're declaring our method. And this is our function call statement, which is telling us, hey, this is what we want, the method. This is what we want the method to do. And we have to use, so we're saying, hey, int sum. We already have the method as int num1 as well. Our, our one of the parameters we have passed into our method. So num1 plus num2 is giving us what? The sum. So if num1 is 15 and num2 is 20. So what will be the sum of this of this method. So we can also, and that's the beauty of our user-defined method, is that the specific method can be used. I mean, the sum of norms can be used in all the methods that, and we'll see that going forward in this class. Any question on this? So it's the same thing here. And let's see how we are reusing the code here. So this is our public class. And what is our class name? My class. That's the name of the class. Static. Static is telling me, static here is where is my modifier. That is the modifier. Void is telling me the return type of this method. And this is the name of my method. And you can see here, there is no parameter list because it's optional. It depends on the problem we want to solve. So there is no formal parameters here. Because we don't have a specific list of values or for the parameters. And here's our calibrates, and we have system.how.print. I just got executed, and I just got executed within within this main method. And now this is a method, a user-defined method. This is user-defined. I'm sorry, my writing is terrible. This is user-defined, right? The user is defining it. So I'm just going to call it user def kind of. Which is saying, oh God, this is terrible. Let me write it. Write it a bit smaller. User defined. So this is user defined. The user created, generated, declared this method, my methods. And you can see immediately after the user defined method, what do we have? We have the main method, right? And here, and what are we doing within this main method? What are we doing within this main method? We are reusing this method we declared here. We are reusing it within the main method. Do you understand this? In this user define, what did I do? My method, yeah, thank you, Brinka. My method is I just got executed. That is the method here. That is what this method is doing. It is where it is printing this printing this line of code in new lines. That's what we have said, this method, this function, this method. We have called this method here. And within our main method, which is an inbuilt method, we have reused my method that it is user defined in our main method. And you can see the output here. I just got executed. And that's it. It's a similar example here. And this is just reusing it 3 times. So we're reusing it 3 times, and you can see the outputs in printout in new lines. You don't have to write it one after the other. We're just reusing that specific method. And we will see more complex example. This is just a simple illustration of how we're reusing our code between different methods in our programming. So, any question on this? Any question? Sorry, I didn't clean this, and I need to emulate it. So don't forget, It is very, very important. Despite the fact is user defined, we are defining it. It still has to be within what? Within a class. Very important. You cannot just start and just start writing the method directly. It still has to be what? Within a class. It is defined with the name of the method followed by what? By the parentheses. That tells the compiler, hey, even when parameter is not passed, even when parameter is not passed within the method, it has to be followed by what? By parentheses, which tells the compiler, hey, this is what? This is a method. This is a method, and it's what is a user-defined method. Java provides some predefined, we already talked about this predefined methods, such as the system.out.println, a new line, but you can also create your own method to perform certain actions, which we have discussed in the beginning of this class. So, this is the example of what we have, the example we illustrated earlier. This is a similar example here. And this is where our class, and this is the class name here. And we are declaring our method. And in this method, this is what our modifier, and you can see this is not a static modifier here. This is a public method. Modifier tells us how we do it, how we access our method can be accessed. And this is a public, a public static. It's a public and it's also static method. And it is what the return, this is the return type. Void, it could be integer, we'll see the value, we'll see more of the value returning, we'll see more of the value returning method going forward in this class. And this is the name of the method itself. This is the name of the method. Sum of the numbers, that's the name of the method. And which parameters are we passing in this method, the num1 and the num2, that is the parameters that gives us the sum of this of the norms method. And you can say we have curly braces, which tells us this line of code where are blocks of code related to the specific method. In sum is equals to 1, and that's num1 plus num2. And we are printing the sum, just the example we discussed, and just this is just a brief explanation of the different concept we have just described earlier. So the sum of norms is always what? The name of the method. Static means the method belongs to the specific class. Void, that's our return value for him. And this is indicating that what? It is a public. It is a public, which is telling the modifier is telling how we access. Are we going to access this? And we will see more of the privates. We will see more of the private modifiers and how it works. So that being said, still examples. Okay, I think we will let's end the class here today, and on Tuesday we will start talking more about the return. I told you the return type, and we will talk about return values of type when we're not using void, when we are using data types. We want to return a specific data type. We want to return an integer. In this example, we can return character. We want to return string or double data type. So instead of using void, we can return a specific data type in our user-defined methods. We will discuss this on Tuesday. We will start our discussion here on Tuesday. I guess we need to start writing some code and to see, demonstrate some code and see how this different concepts, different things are working when we're declaring our user-defined methods. Any question? Thumbs up if you understand what we discussed today and there is no questions. Extremely clear. Okay. Thank you, guys. If no question, that will be all for today. I've taken some of your time before now, so you have the remaining 20 minutes to yourself. You know, explore the course material. Let me know if you have any question. And I want to also emphasize, please, let's go just before you leave today. Let's go to our Zybox, our Zybox assignment for lesson 7. Trust me. For lesson 7, we have many things. We have many things to cover for both specification, challenge, activity, as well as our Xylabs. Please, the deadline is on the 17th. That will be next week, Friday. Let's see how well we can go in discussing this concept in lesson 7. I really don't want you to wait until the due date. Don't wait until um next week to start working on your assignments. Please, I'm emphasizing this. Don't wait until next week. There's a lot to cover. We can start working on it. If you have any question, we have, we have discussed, we have introduced some of these concepts. So you don't have to wait until we finish the entire lesson in discussion in class before you start your assignments, because we have so many things to you have so many things to do in this lesson, and I just don't want you to wait until the last minute to start your assignment. You can say, I can always say, that's the beauty of Zybox. That's the beauty of Zybox. I can see your progress, how well you are, you starting your assignment, when you started your assignment, really. When have you made any progress in the last 1 week? So when you just send me messages for extension or a specific accommodation or a specific extension, I will go back to check this information. I will go back and say, Azil, this person really started this assignment. When? When? To what extent has this person gone with this specific lesson? So I will check all this to make my decision if the extension is really required or not. So I want you to really take, you don't have to wait. And most importantly, your Xylabs. Xylabs are very, very important. They take 35% of your total grades. Also, in this lesson, we have some optional activities. They are optionals, to be honest with you. But if you really want to understand more concepts, learn more on this thing, you want to really understand the object-oriented programming, not just Java language itself, but you really want to understand object-oriented programming language, I will implore you to please, take your time, go through the optional activities as well. Go through the optional labs. I'm just recommending that. It helps you to build more. Go through them. If you have any questions, please let me know. Okay, that being said, that will be the end of the class today. Have a wonderful weekend, and I'll see you guys on Tuesday. Thank you. Bye for now.
Thank you.
You're welcome.
Thank you.
You're welcome. Okay, let's put the marketing.